Hey guys, tonight we are mapping the heavens. The world is dark and the oceans are vast, but in the palm of our hand, we hold the key to navigation. We are joining the medieval astrolabe maker. We are going to build the intricate brass computer that guided civilization through the dark. This is a story about stars, metal, and the geometry of the universe. So, before you get comfortable, take a moment to like the video and subscribe. Now look up at the stars, and let's ease into tonight's journey together. The tower is old, the stones are cold. It is midnight, and the city below has fallen into silence. No torches flicker in the streets, no voices rise from the alleyways. The world has surrendered to sleep, but you are awake. You are at the top of the observatory tower, where the wind moves through the open arches like a whisper from the void. The sky above is not empty. It is a sprawling map of light. Thousands of stars, pinpricks in the velvet dark, scattered across the dome of night. Some are bright. Some are faint. Some cluster together in patterns that have names older than any kingdom. Orion, Cassiopeia, the Great Bear. These are the landmarks of the heavens, and you know them all. The workshop is cluttered. Scrolls are piled in corners, their edges curled and yellowed. Some are maps of the earth, some are star charts, some are treatises on geometry written in Arabic, translated from Greek, copied by monks in candlelit rooms. The tables are covered with tools, compasses, dividers, calipers, burins, gravers, files. Each one is worn smooth by years of use. Each one has a purpose. On the floor there are sheets of metal, brass, dozens of them stacked and leaning against the wall. They catch the starlight and throw it back in soft, golden glimmers. This is where the work happens. This is where the heavens are brought down to earth, engraved into metal, made portable, made knowable. You are the astrolabe maker. You are the astronomer. You are the one who translates the infinite into the finite, who takes the dome of the sky and flattens it into a disk that fits in the palm of a hand. This is not simple work. This is not the labor of a blacksmith hammering horseshoes or a jeweler setting stones. This is mathematics made metal. This is geometry made real. Every line you engrave must be perfect. Every angle must be exact. One error, one slip of the hand, and the instrument is useless. The stars will not align. The calculations will fail. Ships will be lost. Pilgrims will wander. The astrolabe must be precise, or it is nothing. You stand at the workbench. The surface is scarred with 1,000 tiny cuts, the marks of tools that have slipped, of compasses that have dug too deep. Your hands are stained with metal. The smell of brass is in your skin. It never washes out completely. It lingers, metallic, sharp. The smell of science, you breathe it in. You are used to it. It is the smell of your life's work. Tonight you begin a new astrolabe. It will take weeks, maybe months. The patron is wealthy. A nobleman who studies the stars, who wishes to navigate by them, who wants an instrument worthy of his station. He has paid in gold. Enough gold to keep you fed for a year. Enough gold to buy more brass, more tools, more scrolls. You have promised him perfection, and you will deliver it. You always do. The first step is the material, brass. You walk to the stack of metal sheets and select one. It is heavy, cold. The sheet is roughly circular but not perfect. It was cast in a foundry, poured molten into a mold, allowed to cool. The surface is smooth but not flawless. There are tiny imperfections, small bubbles, faint discolorations. These will be removed. You carry the sheet to the workbench and lay it down. The sound it makes is solid, a dull thunk. This is the foundation. This is the mater, the mother, the base of the astrolabe. Everything else will be built upon this. Brass is an alloy, copper and zinc, mixed in the heat of a furnace, stirred together until they become one. The copper gives it color, gold, warm, soft, light, even in the dark. The zinc gives it hardness, strength. Brass is the metal of science. It is hard enough to keep its shape, to hold the precision of engraved lines, to endure the years. But it is soft enough to work, soft enough to engrave, soft enough to shape with hand tools. Iron is too hard. It breaks burins. It resists the graver. Gold is too soft. It wears away. It loses its lines. Silver tarnishes, blackens, obscures the markings, but brass is perfect. It does not rust. It does not corrode. It holds its form. It takes the light and gives it back golden and eternal. You run your fingers across the surface of the sheet. It is cool to the touch, smooth. Your hands can feel the weight of it, solid, dense. This piece of brass weighs perhaps 2 pounds, maybe more. It is substantial. When you hold it, you feel the gravity of the task ahead. This metal will become a map of the cosmos. It will hold the positions of stars. It will track the movement of the sun. It will measure the hours of the day and the passage of the seasons. It will be a tool for sailors and scholars, for astrologers and astronomers. It will be beautiful. It will be accurate. It will be yours. The smell of metal is on your hands now. It is always there, but when you handle fresh brass, it intensifies, metallic, almost sweet. It is the smell of electrons, of oxidation, of the chemical reaction between metal and skin. Your hands will smell like this for hours, even after you wash them. It is the mark of your trade. You do not mind. It is a reminder, a connection to the work. You are not just thinking about the stars. You are touching them, shaping them, making them real. You set the brass sheet down and walk to the tool rack. You select a large compass. It is made of iron, the arms long and straight, the hinge tight. At the end of one arm is a steel tip, sharp, pointed. This tip will scribe the circle. You carry the compass back to the bench and adjust the span. The astrolabe will be 6 inches in diameter, a good size. Not too large, not too small, portable, but with enough surface area to engrave detailed markings. You measure carefully. 3 inches from the center to the edge. You tighten the compass. The hinge holds firm. You place the steel tip at the center of the brass sheet. You press down lightly, just enough to make a dimple, a reference point. Then you swing the compass in a slow, deliberate arc. The steel tip cuts into the brass, scree. The sound is high-pitched, metallic. It fills the tower, echoing off the stone walls. It is not loud, but it is insistent. A single note held long and steady. You continue the arc, keeping the pressure even, the motion smooth. The tip moves through the metal, leaving a bright silver line in its wake. The line is thin but visible, a perfect curve. You complete the circle. The two ends of the arc meet. You lift the compass and examine the line. It is perfect, a flawless circle engraved into the brass. This is the perimeter of the mater. This is the boundary of the instrument. Everything you create from this point forward will be contained within this circle. You feel a satisfaction, a small one. The first step is complete. The foundation is laid. But the circle is only the beginning. The brass sheet is still rough, still uneven. It must be cut. You walk to the shears. They are large, heavy, made of iron. The blades are thick and sharp. You position the brass sheet on the bench and align the scribed circle with the edge of the shears. You squeeze the handles. The blades bite into the brass. The sound is a low crunch. The metal resists, then yields. You cut slowly, following the scribed line. The excess brass falls away in strips, curling as it separates. You work your way around the circle, cutting carefully. Each cut must be precise. If you stray from the line, the circle will be imperfect. The astrolabe will be flawed. It takes time, minutes, maybe an hour. You do not rush. Rushing leads to errors. You cut, pause, adjust, cut again. The scrap brass accumulates on the floor. It will not be wasted. You will melt it down later, cast it into new sheets. Nothing is discarded. Metal is too valuable, too difficult to obtain. Every scrap has worth. Finally, the circle is cut. You lift it from the bench and hold it up to the starlight. The edges are rough, jagged. The shears have left burrs and irregularities. This is expected. You carry the disc to the grinding stone. It is a large wheel mounted on a frame turned by a foot pedal. You sit at the stone and place your foot on the pedal. You pump it slowly. The wheel begins to turn. You bring the edge of the brass disc to the stone. The contact produces a harsh grinding sound. Sparks fly. Tiny flecks of brass, glowing orange for a brief moment before they cool and fall. You move the disc along the edge of the stone, smoothing the perimeter. The burrs are worn away. The edge becomes even. circular, smooth. You work methodically, grinding, checking, grinding again. The sound is rhythmic, a low rumble punctuated by the hiss of metal on stone. The smell of heated brass rises, acrid, sharp. You breathe through your mouth. The grinding takes a long time. The entire perimeter must be smoothed. Every imperfection must be removed. When you are finished, the disc is a perfect circle, 6 inches in diameter. The edge is smooth and even. You run your finger along it. No burrs, no roughness, just clean, solid brass. But the disc is not flat, not yet. The casting process leaves the metal slightly uneven. There are high spots and low spots, variations of a fraction of an inch, but in the world of the astrolabe, a fraction of an inch is a chasm. The plate must be perfectly level, perfectly flat. If it is not, the engraved lines will not be accurate. The measurements will be wrong. The instrument will fail. You carry the disc to the anvil. It is a massive block of iron set into a wooden stump. The surface of the anvil is polished, mirror smooth. You have spent years polishing it, using finer and finer abrasives until it reflects like water. This is not a blacksmith's anvil, rough and pitted. This is a precision tool. The flatness of this anvil determines the flatness of everything you create. You place the brass disc on the anvil. It does not sit flush. There is a gap, a tiny space where the metal is warped. You can see it when you look from the side. The disc rocks slightly when you press on it. This must be corrected. You select a hammer. It is not a large hammer, not the kind used to forge iron or shape steel. This is a planishing hammer, small. The head is polished, smooth, rounded. It is designed to flatten, not to deform. You hold it in your hand. The weight is familiar, comforting. You position yourself over the anvil. You raise the hammer and bring it down on the disc. Tink. The sound is clear, musical, a high note that rings in the air. You strike again. Tink and again. Tink. Each blow is controlled, not too hard, not too soft. You are not trying to reshape the metal. You are trying to coax it, to persuade it, to gently compress the high spots and allow the low spots to rise. You work in a spiral, starting at the center and moving outward. Tink, tink, tink. The rhythm is steady, hypnotic. The sound echoes in the tower, bouncing off the stone walls, multiplying, creating a chorus of metallic notes. You strike the disc hundreds of times, thousands. Your arm moves automatically. Up, down, the hammer falls, the metal sings. Tink, tink, tink. You do not think about the motion. Your mind is elsewhere, on the stars, on the geometry, on the lines you will engrave. The hammering is meditation, a repetitive action that frees the mind. You are not merely flattening metal. You are preparing a canvas, a surface upon which the universe will be drawn. The work takes hours. The night deepens. The stars wheel overhead, tracing their slow arcs across the sky. You do not notice. You are focused on the brass, on the anvil, on the hammer. Tink, tink, tink. Eventually, you pause. You lift the disc from the anvil and hold it up. You sight along the edge. It is flat. You place it back on the anvil. It sits flush. No gaps, no rocking. You press down on different points. It does not move. The disc is level, perfectly level. You set the hammer aside. The first phase is complete. The mater is cut, ground, and flattened. It is ready. But now comes the difficult part, the mathematics, the stereographic projection. This is where the astrolabe transforms from a simple brass disc into a model of the heavens. You must take the three-dimensional dome of the sky and flatten it onto a two-dimensional surface. This is not intuitive. The sky is a sphere. The earth is at the center. The stars are fixed to the inside of the sphere, rotating around us. To navigate, to tell time, to measure the positions of celestial bodies, you need to know where they are in relation to the horizon. But the horizon is different depending on where you are standing. The horizon in Baghdad is not the same as the horizon in Cordoba. The stars that are directly overhead in one city are barely visible in another. The astrolabe solves this problem. It is a projection, a map. Imagine standing at the south pole of the celestial sphere and looking up. The north celestial pole is directly above you. The celestial equator is a circle around you, 90 degrees from the pole. The stars are scattered across the dome. Now imagine a flat plane cutting through the celestial equator. This is the plane of the astrolabe. You project each star from the south celestial pole onto this plane. The projection creates a circle. The center of the circle is the north celestial pole. The edge of the circle is the celestial equator. Everything in the northern sky fits within this circle. The further a star is from the North Pole, the further it is from the center of the disk. This is the stereographic projection. It is ancient, Greek. Ptolemy wrote about it. Hipparchus may have invented it. The Arabs perfected it. They built upon the Greek knowledge, refining the mathematics, creating instruments of astonishing accuracy. You are continuing this tradition. You are one link in a chain that stretches back centuries and will extend forward into the future. You sit at the workbench. The brass disc is before you. The surface is blank, golden, waiting. You take a piece of parchment and begin to sketch. The first element is the tympan. This is a plate that sits inside the mater, engraved with the coordinates for a specific latitude. The tympan is the key to making the astrolabe work for different locations. You will engrave lines representing the horizon, the zenith, the altitude circles, the azimuth lines. Each line corresponds to a position in the sky, as seen from a particular place on Earth. You calculate. The patron is in Seville. Seville is at approximately 37 degrees north latitude. You need to draw the projection for this latitude. You use a compass and a straightedge. You draw the celestial equator. This is a circle. Then you draw the Tropic of Cancer and the Tropic of Capricorn. These are smaller circles, offset from the equator. The sun moves between these two lines over the course of the year. You draw the horizon line. This is the most important line. It is the boundary between what is visible and what is hidden. Above the horizon, you can see the stars. Below the horizon, they are blocked by the Earth. The horizon line is not a straight line on the projection. It is a curve. This is because of the projection. The spherical sky is being flattened, and the flattening distorts the geometry. You calculate the curve carefully. You use tables, numbers derived from trigonometry, sine, cosine, tangent. These functions describe the relationships between angles and lengths. They are the language of the astrolabe. You reference a scroll. It contains tables computed by Persian mathematicians. The numbers are precise. You trust them. You have used them before. They work. You mark points on the parchment. Then you connect them with smooth curves. The horizon emerges, a graceful arc across the disk. Above the horizon, you draw the altitude circles. These are parallel to the horizon, marking heights above it. 10 degrees, 20 degrees, 30 degrees. Each circle represents a specific angle of elevation. If a star is on the 30-degree altitude circle, it is 30 degrees above the horizon. You can measure this with the astrolabe. You can determine where you are on Earth. You also draw the azimuth lines. These radiate from the center of the disk like spokes on a wheel. North, east, south, west, and the intermediate directions, northeast, southeast, southwest, northwest. These lines divide the sky into sectors. They allow you to measure the direction of a celestial object. A star on the eastern azimuth line is rising in the east. A star on the southern azimuth line is due south. The parchment is covered with lines, circles and curves and radii. It looks like a maze, a web. But to you, it makes sense. It is a map, a representation of the sky as seen from Seville at any time of the day or night. You study the sketch. You check the calculations. You measure the distances. Everything is correct. The mathematics is sound. Now you must transfer this design onto the brass. This is the most demanding part of the work. You cannot erase brass. You cannot undo an engraved line. Every mark you make is permanent. You must be perfect. You prepare the tools, a scribe, a burin, a graver. Each is a small steel tool with a sharp point or edge. The scribe is for making light reference lines. The burin is for engraving deep, permanent lines. The graver is for decorative work, for adding details and flourishes. You arrange them on the bench within easy reach. You take a fine brush and a small pot of lamp black mixed with water. You coat the surface of the brass disc with a thin, even layer of black. The gold metal disappears beneath the dark coating. This makes the scribed lines visible. When you scratch through the black, the bright brass shows through. You can see what you are doing. You place the parchment sketch beside the brass disc. You use dividers to transfer measurements. You mark the center of the disc. You scribe a small cross. This is the north celestial pole. From this point, everything will be measured. You use the compass to draw the celestial equator. You set the span to the calculated radius and swing the compass. The steel tip cuts through the lamp black, revealing a bright silver line. The circle is perfect. You draw the Tropic of Cancer, then the Tropic of Capricorn, then the horizon line. This is more difficult. The horizon is not a simple circle. It is a curve that must be plotted point by point. You use the dividers to transfer coordinates from the parchment to the brass. You mark dozens of points. Then you connect them with a smooth arc. The scribe moves through the lamp black, scree. The sound is soft but insistent. You work slowly, carefully. Each point must be exact. The curve must be smooth. It takes hours. The tower is silent except for the sound of the scribe and your breathing. The stars continue their slow rotation overhead. You are aware of them always. They are the reason for this work. They are the subject of the instrument you are creating. You are not just engraving lines. You are capturing the cosmos. You are making the infinite finite. You are giving form to the formless. You finish the horizon line and sit back. Your eyes ache. Your hands are cramped. You flex your fingers. You stand and walk to the window. The cold night air washes over you. Below, the city is dark. A few candles flicker in windows. Most people are asleep. But you are awake. You are working. This is your calling. This is what you were born to do. You return to the bench. You draw the altitude circles. Each one requires careful measurement. The spacing between the circles is not even. The projection distorts the distances. Circles near the zenith are closer together. Circles near the horizon are further apart. You calculate, you measure, you scribe. The lines appear in the lamp black, bright and sharp. You draw the azimuth lines. These are easier. They radiate from the center at regular intervals, every 15 degrees. 24 lines in total, dividing the disk into 24 sectors. You use a protractor to measure the angles. You scribe the lines from the center to the edge. The disk now looks like a wheel with many spokes. Basic structure is complete. The tympan is outlined. But these are just reference lines. They are scratched into the lamp black, not engraved into the brass. Now you must make them permanent. You select the burin. It is small, the blade sharp and triangular. You hold it in your hand like a pen. You position the point on one of the scribed lines. You apply pressure and push. The burin cuts into the brass. The metal curls away in a tiny shaving. You push again and again. Slowly, the line deepens. What was a scratch becomes a groove. What was temporary becomes permanent. This is the most delicate work. The burin must be held at the correct angle. The pressure must be constant. If you push too hard, the burin will slip and gouge the metal. If you push too lightly, the line will be faint. Useless. You must find the balance. You must become one with the tool, your hand. The burin, the brass, they are not separate. They are a single system. You are not thinking about the motion. You are the motion. You engrave the celestial equator. You follow the scribed line, cutting through the lamp black into the brass beneath. The burin moves smoothly. The groove deepens. The line is sharp and clean. When you finish, you lift the burin and examine the work. The line is perfect. Uniform width, uniform depth, exactly where it should be. You feel satisfaction, deep and quiet. You engrave the Tropic of Cancer, then the Tropic of Capricorn, then the horizon. The horizon takes the longest. The curve is complex. The burin must follow the arc precisely. You work slowly, millimeter by millimeter. The sound of the burin cutting brass is soft, a whisper, barely audible, but you hear it, you feel it. The resistance of the metal, the give as the burin bites. One slip, that is all it would take. One moment of inattention, one twitch of the hand. The burin would slide off the line and cut where it should not. The brass would be scarred. The instrument ruined, weeks of work wasted. You cannot allow this to happen. You focus, you breathe, you engrave. The rest of the world fades away. There is only the brass, the burin, the line. The horizon is complete. You move to the altitude circles. One by one, you engrave them. 10 degrees, 20 degrees, 30, 40, 50, 60, 70, 80. Each circle is a perfect arc, concentric with the others, evenly spaced according to the projection. You do not rush. Rushing is the enemy. Patience is the virtue. Then the azimuth lines. You engrave each one from the center to the edge. The lines are straight, perfect. They divide the disc into equal sectors. When you are finished, the disc is covered with engraved lines, a complex web of circles and radii. It looks like a drawing, a diagram, but it is more than that. It is a tool, a precision instrument. The lines are not decorative, they are functional. Each one has a purpose. Each one represents a position in the sky. You brush away the lamp black. The coating has served its purpose. It is no longer needed. The brass beneath is revealed, golden, bright. The engraved lines are thin but visible. They catch the light. They stand out against the smooth metal. The disc is beautiful, not in the way a jewel is beautiful, not in the way a painting is beautiful. It is beautiful in its precision, in its accuracy, in the marriage of mathematics and craft. But this is only the tympan. This is only one piece of the astrolabe. There are other components. The Rete, a rotating framework that holds markers for the brightest stars. The alidade, a sighting rule for measuring angles. The throne, a suspension ring for hanging the instrument. Each piece must be made. Each piece must be perfect. But tonight you focus on the mater and the tympan. These are the foundation. Without them, the rest of the astrolabe cannot function. You pick up the tympan and hold it to the starlight. The lines glow, silver against gold. You can see Polaris through the window, the North Star, fixed and unchanging. On the tympan, Polaris would be at the center, the point around which everything else revolves, the anchor of the heavens. You think about the person who will use this instrument, the nobleman in Seville. He will hold this brass disc in his hands. He will rotate the Rete. He will align the stars. He will measure the altitude of the sun. He will tell the time. He will determine his latitude. He will navigate the seas. He will study the heavens. And he will do all of this because of the lines you have engraved, because of the mathematics you have translated into metal. Your work will outlive you. This astrolabe will endure for centuries. It will pass from hand to hand. It will be used, studied, admired. Long after you are gone, this instrument will remain, a testament to your skill, to your knowledge, to your devotion to the stars. You set the tympan aside and pick up the mater, the mother, the main body of the astrolabe. This piece will hold the tympan. It will support the Rete. It will contain all the other components. The mater needs a cavity, a shallow depression where the tympan will sit. You must cut this cavity precisely. The tympan must fit snugly. If the cavity is too deep, the tympan will rattle. If it is too shallow, the tympan will not sit flush. The fit must be perfect. You use a chisel, a small one with a curved blade. You position the mater on the anvil and place the chisel at the edge of the circle you scribed earlier. This circle marks the inner edge of the cavity. Everything inside this circle must be removed. You tap the chisel with a hammer, lightly. The blade cuts into the brass. A tiny curl of metal peels away. You tap again, and again. You work your way around the circle, cutting a groove. Then you move inward, removing the metal in layers. This work is slow, tedious. Each cut removes only a small amount of brass, but you cannot rush. The depth must be uniform. You use calipers to check. You measure the depth at multiple points. If one area is deeper than another, you adjust. You cut less in the deep areas, more in the shallow areas. Slowly, the cavity takes shape. Uniform, even, precise. The brass shavings accumulate on the floor, bright spirals of metal. They glint in the starlight. You sweep them aside periodically. You will collect them later, melt them down. Nothing is wasted. Hours pass. The cavity deepens. You check the fit. You place the tympan into the cavity. It sits. But it is not yet perfect. There are high spots, points where the tympan does not rest flush. You remove the tympan and mark the high spots with a scribe. Then you cut them down. You check again. Better, but still not perfect. You cut more. You check. You cut. You check. This process repeats over and over until finally the tympan sits perfectly in the cavity. Flush. Level. Snug. You lift the tympan out and set it aside. The mater is ready. The cavity is complete. You examine the edge of the cavity. It is smooth, clean, no burrs, no roughness. Just a precise circular depression ready to hold the tympan. You are tired. The work has taken most of the night. The stars have moved. The constellations that were rising in the east are now overhead. Orion is climbing. The Pleiades are high. Dawn is still hours away, but you can feel the passage of time. Your body is weary, your eyes are strained, but your mind is alert, focused. The work is meditative. It clears away all other thoughts. There is only the brass, the tools, the stars. You walk to the window again. The wind has picked up. It is colder now. The air smells of stone and metal and the faint scent of the sea. Seville is inland, but on clear nights you swear you can smell the ocean. The Atlantic, vast and dark. Sailors use the astrolabe to navigate those waters, to find their way across the emptiness, to reach distant shores. Your work makes that possible, your precision, your care. You think about the mathematics, the stereographic projection. It is elegant, beautiful. The way it transforms the sphere into a plane, the way it preserves angles, the way it allows you to measure, to calculate, to know. Geometry is the language of the universe. Circles, triangles, ratios, these are not human inventions. They are discoveries. They exist whether we know them or not. The stars move in circles. The earth is a sphere. These are facts, truths. And the astrolabe is a tool for understanding these truths, for making them visible, tangible. You return to the workbench. There is more work to do. The mater needs markings. Around the outer edge you will engrave a scale, 24 hours, each hour divided into smaller increments, minutes. This scale allows the astrolabe to function as a clock. When the Rete is rotated to match the position of the stars, the scale shows the time. Not just the hour, but the minute, precise, accurate. You use a compass to divide the edge of the mater into 24 equal sections. Each section is 15 degrees. You mark the divisions with the scribe. Then you engrave them with the burin. Each mark is a small line radiating inward from the edge. The lines are evenly spaced, perfectly aligned. Between the hour marks, you add smaller marks for the half hours, the quarter hours. The divisions become finer, more numerous. The edge of the mater becomes a dense forest of tiny lines. You engrave numbers, Roman numerals, 1 through 24, or perhaps you use Arabic numerals. The patron has requested Arabic numerals. He is a scholar. He appreciates the elegance of the Arabic system. The zero, the place value, you engrave carefully. Each numeral must be legible, clear. The strokes must be uniform. The spacing must be even. You work letter by letter, number by number. The burin cuts through the brass. The numerals appear precise, professional. This work takes hours. The engraving of the hour scale, the addition of the numerals, the refinement of every mark. But when it is finished, the mater is transformed. It is no longer just a brass disc with a cavity. It is the foundation of an instrument, a tool for measuring time and space, for navigating the world, for understanding the heavens. You set the burin aside. Your hand is cramping, your fingers are stiff. You flex them, you massage the palm. The work is physically demanding, not in the way that swinging a hammer is demanding, but in the sustained precision, the constant tension, the need to control every motion, every stroke. It wears on you, but it is worth it. The result is worth the effort. You examine the mater. The surface is covered with lines and numbers. The brass is no longer blank. It is a page, a text written in the language of geometry. You run your fingers over the engravings. You can feel the grooves, shallow but distinct. This is permanent. This will last. The brass will not corrode. The engravings will not fade. Centuries from now, someone will hold this disc and see the same lines you have cut. They will read the same numbers. They will use the same scale. Your work is a bridge. Connecting the present to the future. Connecting the earth to the stars. You think about the other pieces, the Rete, the Alidade. These will come later. Tonight you have accomplished much. The mater is cut, flattened, and engraved. The tympan is complete. The foundation is laid. The astrolabe is taking shape, but there is still much to do. The Rete is the most complex component, a delicate framework of brass cut into intricate shapes. It will hold pointers for the brightest stars. Sirius, Vega, Altair, Betelgeuse. Each pointer must be positioned precisely. The Rete must rotate smoothly over the tympan. The stars must align with the altitude and azimuth lines. The mechanism must work perfectly. But that is for another night. Tonight you have done enough. You cover the mater and tympan with a cloth to protect them from dust. You put away the tools, the compass, the dividers, the burins, each one returned to its place. The workbench is cleared. The brass shavings are swept into a pile. You will melt them tomorrow. Nothing is wasted. You walk to the window one last time. The stars are still there. Unchanging, eternal, Polaris, Cassiopeia, Orion, they have watched you work. They have been your silent companions through the night. You nod to them. An acknowledgement, a thank you. They do not respond. They do not need to. They are the stars. Indifferent, distant, perfect. You descend the stairs of the tower. Your legs are stiff. The stone steps are worn smooth by centuries of footsteps. How many astronomers have climbed these stairs? How many have stood at the top and looked up at the sky? You are one of many, part of a tradition, a lineage. The knowledge you possess was passed down to you, and you will pass it on to apprentices, to students, to anyone who wishes to learn. The stars belong to everyone. The astrolabe is a tool for all. It does not matter who you are, where you come from. If you can read the instrument, you can navigate, you can measure, you can know. You reach the bottom of the stairs and step out into the courtyard. The air is cold, crisp. The sky is beginning to lighten in the east. Dawn is coming. The stars will fade. The sun will rise. The day will begin, but you will sleep. You have earned it. The work is hard. The hours are long, but it is meaningful. It is important. You are making something that matters, something that will endure. You cross the courtyard to your quarters, a small room with a bed and a table. Simple, functional. You do not need much. Your life is in the tower, in the workshop. Among the brass and the stars, you remove your apron. Your hands are covered with metal dust. Brass, silver, iron, the smell is strong. You wash your hands in a basin. The water turns dark. But the smell remains. It always does. It is part of you now, ingrained, permanent. You lie down on the bed. Your body is exhausted, but your mind is still active, thinking about the astrolabe, about the Rete, about the calculations, about the stars. You close your eyes. The darkness behind your eyelids is filled with circles, lines, numbers, the geometry of the heavens. It is beautiful, hypnotic. You drift. The boundary between waking and sleeping blurs. You are still in the workshop, still engraving, still measuring. But now the brass is infinite. The lines extend forever. The stars are within reach. You can touch them, feel their cold fire. They sing to you, a chorus of light, metallic, cosmic. And then you are asleep, dreaming of brass and stars and the geometry that binds them. The astrolabe is not finished, but it will be one day, one perfect day, and it will be beautiful. You wake in the afternoon. The sun is high. Light streams through the small window of your quarters. You rise slowly. Your body is stiff from the night's work. Your hands ache. The fingers are swollen at the knuckles. This is common. This is the price of precision. You flex them, work the joints. The stiffness fades. You dress and walk to the basin. You wash your face. The water is cold. It sharpens your mind, clears away the fog of sleep. You eat bread and cheese. Drink water, simple food. You do not need luxury. Your wealth is not measured in gold or land. It is measured in knowledge. in skill, in the instruments you create. The astrolabe you are building will be worth more than its weight in silver, not because of the metal, because of the craft, because of what it can do. You climb the stairs to the tower. The workshop is as you left it. The mater and tympan are covered with cloth. The tools are in their places. The scrolls are stacked in the corners. Everything is orderly, controlled. This is essential. Chaos leads to errors. Order leads to precision. You uncover the mater and tympan. The brass gleams in the afternoon light. The engraved lines are sharp, clear, perfect. You examine them closely, looking for flaws, for mistakes. You find none. The work from last night is solid. The foundation is complete. Now you must build upon it. Now you must create the Rete. The net, the spider's web. This is the most artistic part of the astrolabe, the most delicate, the most beautiful. The Rete is a skeletal framework of brass that sits above the tympan and rotates around the center pin. It is not solid. Most of the metal is cut away. What remains is a network of curved arms and pointers. Each pointer represents a star, the brightest stars, the most important: Sirius, Betelgeuse, Arcturus, Vega, Altair, Aldebaran, Spica, Regulus, and Teres. Fomalhaut, these are the navigational stars, the markers of the heavens. Sailors use them, travelers use them, astronomers use them, and the Rete displays their positions. The Rete is also a representation of the ecliptic, the path of the sun through the stars. Over the course of a year, the sun moves through the zodiac: Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, Pisces. The ecliptic is a circle offset from the celestial equator. It is tilted. This tilt is why we have seasons. When the sun is high in the sky, it is summer. When it is low, it is winter. The Rete shows this. The outer edge of the Rete traces the ecliptic. It is marked with the signs of the zodiac, the dates when the sun enters each sign. You take a fresh sheet of brass, larger than the mater, thinner. The Rete must be light. If it is too heavy, it will not rotate smoothly. You carry the sheet to the workbench and begin to mark it. First, the outer circle. You use the compass. The diameter is slightly larger than the mater. The Rete must fit over the tympan without touching the edges of the cavity. You scribe the circle. Then you mark the center. This will align with the center of the mater, the north celestial pole. You sketch the design on parchment first. The Rete is complex. It cannot be improvised. Every line must be planned. Every curve must be calculated. You draw the ecliptic, a circle offset from the center, tilted at 23.5 degrees. This is the obliquity of the ecliptic, the angle between the celestial equator and the ecliptic. This angle is the reason for the seasons. You mark the positions of the zodiac signs around the ecliptic. Each sign occupies 30 degrees. 12 signs, 360 degrees, a complete circle. Then you mark the star pointers. You calculate the position of each star using the stereographic projection. Each star has coordinates: right ascension and declination. These are like longitude and latitude, but for the sky. Right ascension measures position along the celestial equator. Declination measures position north or south of the equator. You convert these coordinates into positions on the flat projection. This requires mathematics, trigonometry, the same functions you used for the tympan. Sine, cosine, tangent. You work carefully. Each star must be placed precisely. If a star pointer is even slightly wrong, the astrolabe will give incorrect readings. You reference tables, star catalogues compiled by Arab astronomers, Al-Sufi, Al-Battani. Their observations are meticulous. Their measurements are accurate. You trust their data. You have verified it yourself. Many nights spent on this tower, looking up, measuring, confirming. The stars are where the tables say they are. Sirius, the dog star, the brightest star in the night sky. You mark its position on the sketch, a pointer extending from the Rete framework. The pointer is shaped like a small flame or a teardrop, elegant, distinctive. You mark Betelgeuse, the red giant in Orion's shoulder, Arcturus, the bright orange star in Boötes, Vega, the brilliant blue-white star in Lyra, Each star gets a pointer. Each pointer is unique, not in position but in shape. Some are longer, some are shorter, some curve gracefully. Some are straight. This is not random. This is intentional. The shapes help identify the stars. Even in dim light, you can tell which pointer is which by its form. You mark all the major stars, 20, 30. The number varies depending on the design. Some astrolabes have many stars, some have few. For this instrument, you decide on 25, enough to cover the entire sky, enough to navigate anywhere, but not so many that the Rete becomes cluttered, crowded, difficult to read. The sketch is complete. You study it. The Rete looks like a web, a delicate tracery of lines and curves. Most of the circle is empty space, negative space. This space will be cut away. Only the framework will remain. The solid parts are minimal, just enough to support the star pointers, just enough to trace the ecliptic. Everything else is removed. You transfer the design to the brass. You use the scribe. You mark the outer circle, the inner circle, the ecliptic, the star pointers. Each line is scratched into the metal, bright against the gold. You work slowly, checking and rechecking, comparing the brass to the parchment sketch, making sure every mark is correct, every position accurate. When the design is fully transferred, you step back and look at it. The brass disc is covered with lines. It looks chaotic, a maze of curves and radii. But within the chaos is order, structure, meaning. This is the skeleton of the Rete. Now you must remove everything that is not Rete. You must cut away the negative space. You must leave only the essential framework. This is the most challenging part. The cutting, you cannot use shears for this. Shears are too crude, too imprecise. You need a saw, a piercing saw, a small tool with a thin blade held in a frame. The blade is fine, barely thicker than a hair. It can cut tight curves, intricate shapes, but it is fragile. If you push too hard, it will snap. If you twist it too sharply, it will break. You must be gentle, patient. The saw will do the work, you just guide it. You drill a small hole in the brass, just inside the line you have scribed. This hole will be the starting point. You thread the saw blade through the hole and attach it to the frame. You tighten the blade. It should be taut, like a string on a lute. Too loose and it will wander. Too tight and it will snap. You test it. You pluck it with your finger. It makes a soft ping. The tension is correct. You position the brass on the workbench. You hold it steady with one hand. With the other, you hold the saw. You begin to cut. The blade moves back and forth. You push gently. The teeth bite into the brass. The sound is distinctive, high-pitched, rhythmic. Ziz, 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 a metallic whisper. The blade cuts through the metal, slowly. The kerf is narrow. The line is clean. You follow the scribed line, guiding the saw, not forcing it, letting it move at its own pace. Ziz, ziz, ziz. The sound fills the tower. It is not loud, but it is constant, hypnotic. You fall into the rhythm. Push, pull, push, pull. The blade moves, the metal parts. A thin curl of brass falls away. You continue, following the curve. The saw cuts through the thickness of the sheet, emerging on the other side. The negative space is removed, one small piece at a time. You work for hours, cutting. Each section of negative space requires a new starting hole, a new threading of the blade. You drill, you thread, you cut. Ziz, ziz, ziz. The sound becomes part of you. Your breathing matches the rhythm. In, out, in, out. Ziz, ziz, ziz. You are not thinking, you are doing. The saw is an extension of your hand. The hand is an extension of your will. The will is focused on the design, on the Rete, on the perfection of the cut. The negative spaces fall away. Large pieces, small pieces. The brass disc becomes lighter, more open. The framework emerges, the ecliptic ring, the star pointers, the connecting arms. It looks delicate, fragile, like it might break if you breathe on it. But brass is strong. The framework will hold. It will support itself. It will rotate smoothly over the tympan. You cut away more metal. The saw moves. Ziz, ziz, ziz. You are careful around the star pointers. These are the most delicate parts, thin extensions of brass. If you cut too close, they will weaken. If you push too hard, they will bend. You guide the saw with precision. The blade follows the scribed line. Exactly. No deviation, no error. Hours pass. The afternoon becomes evening. The light changes. The sun sets. You light candles. The workshop is bathed in warm, flickering light. The brass glows. Orange, gold, the shadows deepen. But you continue. The work is not finished. The cutting must be completed. You cannot stop halfway. You cannot leave the Rete incomplete. It would be vulnerable, exposed. You must finish. Ziz, 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 the saw sings. You cut the last section of negative space, a large piece near the edge. The blade moves through the brass. The metal parts, the piece falls away. You set the saw aside. The cutting is complete. The Rete is freed from the excess metal. You hold it up to the candlelight. It is beautiful, a skeletal web of brass, delicate and strong. The star pointers extend like flames, like branches, like reaching fingers. The ecliptic ring frames everything. Elegant, perfect. But the edges are rough. The saw leaves marks, small irregularities, burrs. These must be removed. You select a file, a fine file. The teeth are small and closely spaced. You work the file along the edges of the Rete, smoothing, refining. The file removes the burrs, the roughness. The edges become smooth, rounded. They gleam in the candlelight. You file each star pointer, each section of the framework. The file moves back and forth. The sound is softer than the saw, a gentle rasp. SHHHHSHHHHSHHHH. The file removes metal, tiny amounts, dust more than shavings. The brass dust falls. It glitters like gold powder. You work slowly. You cannot rush this. Filing is about control, about finesse. Too much pressure and you remove too much metal. The Rete becomes weak. Too little pressure and the burrs remain. The edges stay rough. You find the balance. The file moves smoothly. The edges transform. You work for more hours, filing, checking, filing again. You run your finger along the edges. They are smooth. No burrs, no sharp points, just clean, rounded brass. The Rete is becoming refined. The rough is becoming smooth. The functional is becoming beautiful. But the edges are not just smooth, they are shaped. You use smaller files, needle files. You carve the edges into decorative forms. The star pointers become flame-shaped, teardrop-shaped. The ecliptic ring is beveled. The connecting arms are sculpted. This is where art meets science. The Rete must function, but it must also be beautiful. The patron is paying for both, precision and aesthetics. You provide both. You work the files with care, shaping, sculpting. The brass responds. The edges transform. What was plain becomes ornate. What was simple becomes elegant. The star pointers look like vines, like flames, like flowing water frozen in metal. The Rete is no longer just a tool. It is a work of art. The night deepens. The candles burn low. You replace them. New candles, more light. The work continues. You cannot stop. You are in the flow, the state where time loses meaning, where there is only the work, the brass, the tools, your hands. They move without thought, guided by skill, by experience. By the thousands of hours you have spent doing this, the muscle memory is deep, ingrained. Your hands know what to do. You just let them work. Finally, the filing is complete. The Rete is smooth, shaped, perfect. You set the files aside. You hold the Rete up to the candlelight again. It is transformed, no longer rough, no longer crude. It is refined, elegant, a masterpiece of brass work. The negative space dominates. The solid parts are minimal, just enough framework to support the star pointers. To trace the ecliptic, the Rete is light, delicate, beautiful. But it is not finished. The stars need names. Each pointer must be labeled. Otherwise, how will the user know which star is which? You must engrave the names in Latin or Arabic. The patron has requested Arabic. He is a scholar of the Arab sciences. He appreciates the Arabic tradition. The contributions of Islamic astronomers. You will honor this request. You prepare the brass. You apply lamp black, a thin coating over the Rete. The black obscures the gold, but it allows you to see the scribe lines. You mark the positions where the names will be engraved. Next to each star pointer, small spaces. The letters will be tiny, precise, legible but not large. There is limited space on the Rete. The names must fit. You reference a scroll, a star catalogue in Arabic. You find the names: Al-Shira, that is Sirius; Al-Mankib, that is Betelgeuse; Al-Simak Al-Rami, that is Arcturus; Al-Nasser Al-Waki, that is Vega. Each name is written in elegant script, flowing, cursive. Arabic calligraphy is beautiful. It is an art form. You have studied it, practiced it. You can write it, not as well as a trained calligrapher, but well enough, legibly, accurately. You select the finest burin. The tip is sharp, needle sharp. You position it on the brass, next to the pointer for Sirius. You begin to engrave Al-Shira. The burin cuts into the brass. The lamp black peels away. Bright metal appears beneath. You form the letters slowly. Each stroke must be precise. The curves must be smooth. The lines must be even. Arabic script is flowing, continuous. One letter connects to the next. You cannot lift the burin. You must maintain the flow, the rhythm. The burin digs into the brass. A curl of metal rises. Thin, delicate, like a shaving of gold. It curls away from the tip. You continue. The letter is complete. You move to the next, and the next. The name takes shape. Al-Shira, beautiful, legible, perfect. You engrave the next name, Al-Mankib. The letters are tiny, each one perhaps a quarter of an inch tall, maybe less, but they are clear, sharp. The burin moves with precision, cutting the brass, forming the script. You work slowly. This is delicate work. One slip and the letter is ruined. The name is illegible. You cannot slip. You focus. The world narrows to the point of the burin. The brass, the letter, nothing else exists. You engrave all the names, 25 stars, 25 names, each one written in Arabic script, each one perfect. The work takes hours, the night is deep. The candles burn down, you replace them again. The workshop is silent except for the soft sound of the burin cutting brass. A whisper, a sigh, the metal yields, the names appear. Al-Simak Al-Rami, Al-Nasser Al-Waki, Al-Dabaran, Al-Fard. Each name is a prayer, a recognition. These stars have been named for thousands of years, by countless cultures. The names you engrave are Arab, but before the Arabs the Greeks named them, and before the Greeks the Babylonians, and before them others, lost to time. The stars remain, unchanging, eternal, and we brief and mortal give them names, mark them, claim them, make them our own. When the engraving is complete, you brush away the lamp black. The names appear, bright against the brass, beautiful, legible. The Rete is nearly finished, but there is one more element, the zodiac. The ecliptic ring must be marked with the signs: Aries, Taurus, Gemini, the 12 signs, each occupying 30 degrees of the circle. You divide the ecliptic ring into 12 equal sections. You mark the divisions. Then you engrave symbols, not words, symbols: the ram for Aries, the bull for Taurus, the twins for Gemini. Each symbol is small but recognizable. You engrave with care. The symbols must be clear, distinct. The user must be able to identify them at a glance. The engraving of the zodiac takes more hours, but you do not tire. You are in the rhythm, the flow, the burin moves, the brass yields, the symbols appear. When the last symbol is engraved, you set the burin aside. The Rete is complete. You hold it up to the candlelight. It is extraordinary, a work of art and science. The skeletal framework, the star pointers, the names, the zodiac, all combined into a single, elegant piece of brass. This is the heart of the astrolabe, the moving part, the element that makes it work. You set the Rete aside and turn your attention to the next component, the alidade. This is a ruler with sights. It attaches to the back of the astrolabe. The alidade is used to measure the altitude of celestial objects: the sun, the moon, the stars. You hold the astrolabe by its suspension ring. You rotate the alidade until the sights align with the object you are measuring. Then you read the angle from a scale engraved on the back of the meter. This angle is the altitude, the height above the horizon. The alidade is simpler than the Rete, a straight ruler with two sights at either end. The sights are small plates with holes. You look through one hole and align the other hole with the celestial object. When the object is visible through both holes, the alidade is aligned. You read the angle. You take a strip of brass, straight, flat. The length is equal to the diameter of the mater. You file the edges smooth. Then you drill holes at either end, small holes, precise. These holes will hold the sights. You cut small squares of brass for the sights. You drill a hole in the center of each square. The hole is small, perhaps a quarter of an inch in diameter. You file the edges of the squares, smooth, even. Then you attach the sights to the ends of the ruler. You use small rivets. You hammer them carefully. The sights are secure, perpendicular to the ruler. The holes align with the edge of the ruler. The alidade is functional, but it is plain. You engrave a decorative border along the edge, simple lines, geometric patterns. The patron appreciates beauty. Every component should be refined, elegant. You engrave carefully. The patterns emerge. The alidade is transformed, no longer plain, now elegant. But the back of the mater also needs work. You must engrave scales for measuring altitude, for calculating trigonometric functions, for converting between different systems of time. The back of the astrolabe is as important as the front. It is a calculator, a mathematical tool. You mark the scales, using the compass and dividers, circles and radii. Each scale has a purpose. Each marking has meaning. You engrave the altitude scale, 0 to 90 degrees, divided into degrees, each degree marked. Some scales have even finer divisions, half degrees, quarter degrees. The more precise the scale, the more accurate the measurements. You engrave carefully. Each mark must be exact, each number legible. You engrave additional scales, a shadow square, for measuring the height of objects using their shadows, a calendar scale, for determining the position of the sun in the zodiac on any given day. These scales are complex. They require careful calculation, precise engraving. You work slowly, methodically. Each mark is checked, each number verified. The engraving of the back takes as long as the engraving of the front, maybe longer. There is so much information to include, so many scales, so many numbers. But you do not rush. You cannot rush. This is precision work. The astrolabe must be accurate. If the scales are wrong, the calculations will be wrong. The instrument will fail. Hours pass. The night is late or early. You have lost track of time. The candles have been replaced multiple times. The workshop is filled with brass dust, shavings, scraps, the evidence of labor. But the work is nearly complete. The back of the mater is engraved. The alidade is finished. All that remains is assembly. You gather the components. The mater, the tympan, the rete, the alidade. Each piece is perfect. Now they must be combined. You place the tympan into the cavity in the mater. It fits perfectly. Flush. Level. You place the rete over the tympan. It sits lightly. Centered. The star pointers extend over the tympan. The ecliptic ring frames everything. Now you need the pin, the central axis. This pin will hold all the components together. It will allow the rete to rotate. The pin must be precise, smooth, perfectly cylindrical. You select a rod of brass. You chuck it in a lathe. You turn it slowly. The cutting tool removes metal. The rod becomes cylindrical, uniform. You measure with calipers. The diameter must match the hole in the center of the mater. Exactly. Not too large, not too small. You turn the rod until the diameter is perfect. You cut the rod to length, just long enough to pass through the mater, tympan, and rete with a bit extra for riveting. You file the end, smooth, rounded. Then you insert the pin through the center of the rete, through the tympan, through the mater. It slides through smoothly, no resistance. The fit is perfect. You place a washer on the back of the pin, a small brass disc. This will prevent the pin from pulling through. Then you rivet the end of the pin. You use a hammer, light taps. The end of the pin mushrooms, expands. It locks the washer in place. The components are held together, secure, but not too tight. The rete must still rotate. You check. You rotate the rete. It turns smoothly, effortlessly, perfect. You attach the alidade to the back of the mater. Another pin through the center, smaller, lighter. The alidade rotates independently of the Rete. You can measure altitude while the Rete shows the positions of the stars. The astrolabe is multifunctional, versatile. The final component is the throne, the suspension ring. This is a decorative bracket at the top of the mater. The throne holds a ring, a loop of brass. You hold the astrolabe by this ring. When you suspend it, gravity keeps it vertical. This is essential for accurate measurements. The astrolabe must hang plumb. The throne is shaped like a Gothic arch, elegant, ornate. You have engraved it with decorative patterns, tracery, filigree. It is beautiful, a fitting crown for the instrument. You attach the throne to the mater. Small rivets, carefully hammered. The throne is secure. You slip the suspension ring through the throne. The ring moves freely. You lift the astrolabe by the ring. It hangs vertically. Perfect. The weight is distributed evenly. The instrument is balanced. The astrolabe is complete, every component assembled, every engraving finished. You hold it in your hands. It is heavy, solid. The brass is cool, smooth. You rotate the Rete. The star pointers sweep across the tympan. The mechanism is smooth, silent. The craftsmanship is flawless. You walk to the window. The night is clear. The stars are bright. Polaris is visible, fixed in the north, unchanging. You hold the astrolabe by the suspension ring. You let it hang. The weight pulls it vertical. You rotate the Rete until the pointer for Polaris aligns with the north point on the tympan. Then you look at the hour scale. The Rete indicates the time. Midnight. Exactly. You check the sky. The position of the stars. It is correct. The astrolabe is accurate. You step out onto the balcony. The cold night air washes over you. The city below is dark, silent. The world is asleep, but you are awake. You are testing the instrument, verifying its accuracy. You hold the astrolabe up. You sight through the alidade. You align the sights with a star, Arcturus, low in the western sky. You read the altitude from the scale on the back, 23 degrees. You verify with your own observations. Correct. The astrolabe works. You measure other stars. Vega, Altair, Deneb, each measurement is accurate. The scales are precise. The engraving's correct. The astrolabe is a success, a perfect instrument. You feel satisfaction, deep and profound. This is the culmination of weeks of work, hundreds of hours, thousands of careful motions. And the result is perfection. An instrument that will last for centuries, that will guide travelers, navigate seas, measure time, calculate positions. This astrolabe will outlive you. It will outlive your children. It will become an heirloom, a treasure, a link to the past. You lower the astrolabe. You run your fingers over the Rete, the star pointers, the names, the craftsmanship. This is your legacy, not gold, not land, not titles. This, the instruments you create, the knowledge you preserve, the stars you map. This is what matters. This is what endures. You return to the workshop. You place the astrolabe on the workbench. You cover it with a cloth. Tomorrow you will deliver it to the patron. He will be pleased. You are certain. The astrolabe exceeds expectations. It is accurate, beautiful, functional, everything he requested, everything you promised. But tonight you are finished. The work is complete. Your body is exhausted. Your hands ache. Your eyes burn. But your mind is satisfied, content. You have created something worthy, something meaningful. You have brought the heavens down to earth, made them portable, knowable. This is your calling, your purpose. You extinguish the candles, one by one. The workshop darkens. Only the starlight remains, filtering through the windows, casting soft silver light on the brass, on the tools, on the scrolls. The tower is silent, peaceful. You stand for a moment in the darkness, looking at the stars. They do not change, they do not age, they are eternal. And you, brief and mortal, have captured a moment of their dance, frozen it in brass, made it permanent. You descend the stairs. Your legs are heavy, tired. The stone steps are cool beneath your feet. You reach the bottom and walk across the courtyard. The air is cold. The sky is vast, filled with stars. More stars than you could ever count, more than you could ever name. But you know the important ones, the bright ones, the navigational stars. They are your friends, your companions. You have spent countless nights with them, observing, measuring, recording. They are as familiar to you as the streets of the city, as the stones of the tower. You enter your quarters, you wash your hands. The water is cold. The brass dust washes away. But the smell remains, metallic, sharp, the smell of your work, of your life. You dry your hands. You remove your apron, your tunic. You lie down on the bed. The mattress is thin but comfortable. You have slept on worse. You close your eyes. The darkness is immediate, complete. But behind your eyelids you see the astrolabe, the Rete rotating, the star pointers sweeping across the tympan, the ecliptic ring tracing the path of the sun, the alidade measuring altitude, the scales calculating functions. The instrument is alive in your mind, moving, working, perfect. You think about the user, the nobleman in Seville. He will hold this instrument, he will use it. He will look up at the stars and understand. He will measure, calculate, navigate. The astrolabe will be his companion, his tool, his window to the cosmos. And every time he uses it, he will think of you, the maker, the astronomer, the craftsman who brought the heavens down to earth. You drift toward sleep. The boundary blurs. You are still in the workshop, still engraving, still measuring. But now the stars are within reach. You can touch them. They are brass, cold and heavy. They sing to you, a chorus of metallic notes. Tink, tink, tink. Ziz, 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 the sounds of creation, the sounds of craft. You rotate the Rete. The stars move. The heavens turn. Time flows. The sun rises and sets. The seasons change. But the astrolabe remains, constant, accurate, true. The stars outside continue their slow march across the sky, turning the great wheel of the night. Polaris holds the center, unchanging. The constellations rotate around it. Orion climbs, the Pleiades follow. Cassiopeia descends. The dance is eternal, ancient. It has been happening since before humans existed. It will continue long after we are gone. But for a brief moment you have captured it, translated it into brass, made it comprehensible, portable, human. The instrument rests on the workbench, covered with cloth, protected, waiting. Tomorrow it will be delivered, placed in the hands of its new owner. It will begin its journey, its purpose. But for now it rests, silent, still. The brass cools in the night air. The engravings hold their secrets, the mathematics embedded in metal, the geometry of the universe made manifest. You sleep deeply, dreamlessly. The work is done, the task complete. There is no need for dreams. Reality is sufficient. The astrolabe exists, perfect and complete, a testament to human ingenuity, to the marriage of art and science, to the desire to understand, to know, to measure, to navigate the world and the stars above. The tower stands silent, the workshop empty, the tools arranged in their places, the scrolls stacked in corners, the brass shavings swept into piles. Everything is orderly, ready for the next project, the next instrument. There will always be another. Someone will need an astrolabe, a quadrant, an armillary sphere, some tool to measure the heavens, and you will make it with the same care, the same precision, the same devotion. This is your life, your work, your purpose. You are the astrolabe maker, the astronomer, the keeper of celestial knowledge. You stand between the earth and the stars, translating, interpreting, making the infinite finite, the unknowable knowable. This is sacred work, not in a religious sense, but in a deeper sense. It is the work of understanding, of seeking truth, of bringing order to chaos. The night deepens, the stars wheel overhead. The universe expands, contracting and expanding, breathing, alive, and somewhere in this vast cosmos, on a small planet orbiting a small star, in a city on the edge of a continent, in a tower of stone, an astrolabe rests, a disk of brass, 6 inches in diameter, engraved with lines and numbers and names, a tool, an instrument, a work of art, a bridge between earth and sky. And as the stars continue their slow march across the sky, turning the great wheel of the night, the instrument rests. The work is done. Sleep well.